Hello everyone, I welcome you all for today's session. So in today's session we'll be dealing with a problem on Kilbridge and Wester's method. It is a part of module number 3. In the previous session we have done a problem on largest candidate rule. So this is second method of line balancing. So let us start with the problem. I have written down the statement for you people. Let us go through that. Following table gives the individual work elements in an assembly line to replace a group of assembly workers. The demand rate for this job is 2400 units per week. Assume the working hours as 40 hours per week. Construct the precedence diagram. Use the KW method to assign work elements to workstations and determine the number of stations required. Calculate the balance delay. Right. So these are the three things. Same things what we have done previously, but allocation of workstations is using KW method. In the last problem it was using LCR method. Right, so let us check out what input data he has given us. Oh, it's quite big. So he has given 12 work elements. TEE is work element time for each of the element. So this is the predecessor. Okay, first prerequisite is cycle time. So let me calculate cycle time. So that would be my starting of the solution. So let me start with the solution part of the problem. So initially RP, which is production rate, is calculated as demand rate 2400 units per week divided by working hours, which is 40 hours per week. So here week and week gets cancelled. 41s are 40 into 60, which is 2400. So it is 60 units per hour. But since my work element time is in minutes, I will convert this hour to into minutes. So if you want to convert hour into minutes, you should divide by 60. That is what I have done. 60 divided by 60. The outcome is 1 unit per minute. We all know that TC is equal to 1 divided by RP. So value of RP is 1. So 1 divided by 1, the outcome is 1 minutes per unit. So the cycle time for this particular problem is 1 minute. Right? Fine. So this is the prerequisite required. So next we'll be starting with the first bit, that is construction of precedence diagram. Okay. Let me start with construction of precedence diagram. Okay, I need to start with 1 and 2 because it does not have any precedences. But I need to start with 1 and 2, it does not have any precedences. So let me take 1 here and 2 here. Work element time for 1 is 0.2 minutes. You need to write it on the top of the circle. Work element time for 2 is 0.4 minutes. Right, so next the predecessor for 3 is 1. If you just check out the input table what he has given me, that is this table, just check out the predecessor for 3 is 1 and for 4 it is 1 and 2. So let me draw this one. For 3 it is 1. Right, so let me take 3 here. So the time here is 0.7, and for 4 it is 1 and 2. So let me take 4 here. So it is 1 and 2. Work element time for 4 is 0.1. Similarly, predecessor for 5 is once again 2. So if I want 2 as a predecessor, there is no other option. I need to give 5 over here. The work element time for 5 is 0.3. Okay, now here what you need to observe is these 3, 4 and 5 are having few common predecessors. What I mean, if we just check out 3 and 4, 1 is a predecessor for 4 also, 1 is a predecessor for 3 also. So such work elements should fall in a single vertical straight line, or they should fall in a single vertical column. Okay, you can also check it here. For 5 and 4, 2 is a common predecessor, so 4 and 5 should fall, or you should draw it in a single straight line. So that is very important when you are doing KW method. Next predecessor for 6 is 3. Okay, predecessor for 6 is 3. So the work element time here is 0.11. Next predecessor for 7 is also 3. So let me take it here. 7 is also 3. Once again I am drawing it in the same straight line because it is having a common predecessor. For 8 it is 3 and 4. Okay, let me take 8 over here. Three and 4. Right. So work element time for 7 was 0.32. For 8 it is 0.6. Now for 9 it is 6, 7 and 8. So we are having 6, 7 and 8. Take 9 over here. Work element time for 9 is 0.27. For 10 it is 5, 8. Okay, 5 and 8 both are the predecessors for 10. Now I'll take 10 over here. You don't take it here. If you draw it here, then you are once again going to face a difficulty. Why I am taking it here? Because you can just check out 8 is also a predecessor for 9, and if 10 is also having a predecessor for 9, then 9 and 10 should come in the same vertical column. That is the reason I am taking 10 here. Right? Now this is 1, this is second predecessor. For 10 the time is 0.38. For 11, 9 and 10 are predecessors. So you are having the 9, you are having the 10. So here you will be getting 11. Time is 0.50. And at last you are having 12. Having 12. Time is 0.12. Okay, so that is how you draw the precedence diagram. What you need to take care while drawing the precedence diagram for KW method is elements which are having common predecessors should fall in the same vertical column. Okay, now I'll be drawing few vertical columns over here. These two elements I take it as column 1. These three elements I'll take it as column 2. These three elements I'll take it as column 3, column 4, column 5, and at last it is column 6. Right? So because you are going to assign these work elements to columns in this manner, it is very important to draw the work elements depending upon their precedences under a common vertical straight line. Fine. So once if you are done with this, next I'll go for step number 2. So while constructing precedence diagram, this is the first part. Next, to complete the problem, second step is arrange the work elements according to their columns. Arrange the work elements according to their columns, right? So that is your second step. So your data table will be something similar to this what I am drawing here. Column number, element time in minutes, and next you are having summation TE, and also please note down the predecessor. Okay, no. Okay, and let me start with column number 1. So I'll write column number 1 over here. So in column 1 you are having two elements, 1 and 2. So I'll write 1, I'll write 2. Element times I have noted here, I'll write it 0.2, 0.4. So you are having 0.6. Precedences, both does not have any precedence, so please put a dash mark. Okay, so once if you are done with this part, please draw a horizontal line. Why you are drawing a horizontal line? Because this is the end of column number 1. Column number 1 work elements you have accommodated. Next to go for column number 2. In column number 2 there are 3, 4 and 5. So 3, 4 and 5. Work element times are 0.7, 0.1 and 0.3. Sum of them is 1.1. Immediate precedences, I can just check out the immediate precedences. For 3 it is 1, for 4 it is 1 and 2, and for 5 it is 2. Once again close this, go for column 3. Okay, go for column 3. Check the elements in the column 3, 6, 7 and 8. Okay, so I need to write 6, 7, 8. Work element times for 6 are 0.11, for 7 is 0.32 and for 8 is 0.6, right? And the total work element time is 1.03. Immediate precedences for 6 is 3, for 7 it is 3, and for 8 it is 3, 4. Once if you are done with this, please close this, proceed further, go for column 4. Check out the elements in column 4. This is column 4, 9 and 10, right? So you need to write 9, 10. Work elements for 9 and 10, work element time is 0.27, 0.38, and summation TE is 0.65. The immediate precedences, you just check out what is the immediate precedence for 9. For 9 it is 6, 7, 8, 6, 7, 8, and for 10 it is 5, 8. Okay, very important to write this column. Its importance you will get to know later when I will be allocating workstations. Next, column number 5. In column number 5, there is only one work element, which is element number 11. So I have written it as 11. Work element time is 0.50. Here also it is 0.50. Immediate precedences are 9, 10. So close this. At last we are having 12, having 6, and 0.12. Here also it is 0.12. Precedence is 11. Okay, either you can call it as precedence or predecessor, whatever it may be, both are same. Now we shall allot the workstations. So step number 3 is allocation of workstations depending on the feasible precedence given and the same two conditions what I have followed in largest candidate rule I am going to follow. I am going to check out whether the precedence given is fulfilled and also the summation of work element time for a particular station is less than or equal to the cycle time. So this is how I am going to do it. Now at last I'll be constructing a table. First let me allot it in step number 2 itself, a rough allotment. I'll be doing it here. Okay, and let us check out. I am doing the rough allotment here. So what I will be getting to know here is first point 1 and 2 are the elements. 1 and 2 are the elements which are not having any predecessor, so it means that it should be allotted first. So I'll allot this to station number 1. I'll allot this also to station number 1. Okay, in that case you are having 0.6, but I can still accommodate 0.4 because my cycle time is equal to 1. So you go for the elements in the next column. 0.7 ruled out because I am in need of maximum 0.4. Yes, you are having 0.1 and 0.3. If you add up these up, you will be getting 0.4, and 0.4 plus 0.6 will be equal to 1. So what I can do here is this can also be allotted to station 1 and this can also be allotted to station 1. Right, so that is the maximum what you can allot. Next, go for the next thing. Check out the precedences. Start checking out the precedences. Now I have completed 4 and 5. It means that predecessor 1 and 2, this was done. After doing these two I completed 4, and I also completed 5 because 2 was the precedence which is already done. Now we will just check out for those work elements whose predecessor are 4 and 5, 4 and 5 or 1 and 2. Okay, whichever are the allotted work elements. So these have already been finished. Now you are going to check the precedence and then allot the workstation. So you go for the elements which have precedence 1, 2 and 4 and 5. So if you just check out here, you are having one of such kind. The precedence is 1, 0.7. So I'll allot this to station number 2. Okay, so 0.7 is over. Maximum I can accommodate now is 0.3. So let me check out 0.3. Here you are having 0.11. Precedence is 3. Is 3 already over? Yes, 3 is already over. So I can also give this. So this also comes under S2. Right. In this case I am having 0.7 plus 0.11, which is 0.81, and 0.81 is always less than 1, right? So both the conditions are fulfilled. Now next, if you are having 0.81, 0.19 is still remaining. Now let me check out where you are having anything less than 0.19. okay, here you are having 0.12. okay, this is 0.12, which is less than 0.19, but I will not be allotting this to station 2. Why? Because here my first condition is not fulfilled. I can allocate station 12, I can allocate element number 12 only after completing element number 11, because precedence is 11. Is 11 completed? No. Then you cannot allot 12. So it should follow the precedence order what is given in the problem. So that's it. For station number 2 we are having only 2 elements. You need to stop it there. Next, go for the next station. So for station number 3, no, all these precedences you need to check. Whichever are allotted, you just check out where they come as precedence. Now you can just check out 3. Yes, 3 is already completed, so I can give this to S3, station number 3. So it is 0.32. Next, 3 and 4, both 3 and 4 are completed, so this also I can give to station number 3. So 0.32 plus 0.6 is 0.92, right? Now still 0.08 is remaining, and there are no elements which are less than 0.08. so that's it. That is the end of station 3. Next you go for station number 4. So for station number 4, this I can give it as station number 4. Why? 6, 7 and 8. 6, 7 and 8 all are completed, and 0.27 is less than 1. Now 5 and 8 both are completed. 5 and 8, yes, both are completed. So 0.38, this also I will be allotting it to station 4. Why? 0.38 plus 0.27 is equal to 0.65, and 0.65 is still less than 1. Now 0.35 is still remaining. You just check out if you are having anything less than 0.35. Yes, I am having 0.12, but even now I cannot allot this to station 4. Reason, here precedence 11 should be completed in order to allot 12. So 11 is unallocated, so you cannot allot 12 before allotting 11. So that's it. S4 is over. Now I'll go for station 5. 9 and 10 should be completed. Yes, 9 and 10 are completed. So this I'll go for station 5. Maximum is 0.5. Next, only one thing is remaining. 11 is completed. Yes, 11 is completed. So this also goes to S5, because 0.5 plus 0.12 is 0.62, and 0.62 is always less than 1. Right, so that is how you allot the work elements to the workstations. Right, now whatever I allotted here, I'll just put it in the form of a table. Okay, now if you understand this, you will obviously understand the next table. Okay, and this table is, I'll put the workstation number, I'll put the elements allotted, TE, summation of TE. Okay, so these are the 4 things. First I'll start with station number 1. Now you come back to this and check out wherever you are having station number 1. You are having station 1, station 1. You are having station 1 and station 1. 1, 2, 4 and 5 come under this category. Right, so those things I need to write it here. 1, 2, 4, 5. Respective element times you write it 0.2, 0.4, 0.1, 0.3. So if you just sum it up, it will be 1, which is summation E, which is should be less than or equal to Tc. And in this case, it is equal to Tc. So that is everything related to station 1. So close this. Go for station number 2. Once again, check out where you are having station 2. You are having station 2 here. You are having station 2 here. So 3 and 6 will be coming under station number 2. So 3 and 6 will be coming here. So it is 0.7, 0.11, it is 0.81. Close this. Go for station 3. Once again, check out where you will be getting station 3. S3. You are having S3. 7 and 8. 7, 8. You are having 0.32, 0.6, 0.92, which is once again less than 1. Close this. Go for 4. Just check out where you are having station number 4. This is station 4, 9 and 10. So 9 and 10, 0.27, 0.38, 0.65, which is still less than 1. And at last you go for station 5. So in station 5 there are two elements, 11 and 12. 11 and 12, it is 0.5, it is 0.12, so it is 0.62. Right, so this is your final allocation of work elements to the respective workstations. So this should be your answer table. So therefore number of workstations is equal to 5. In this problem, the number of allocations or workstations required is equal to 5. And at last, in the last step, which is, I guess it is step number 4, we need to calculate balance delay. Right, so balance delay is calculated as n into Tc minus total work content time and divided by n into Tc. So this can also be written as n into Tc minus summation of Te divided by n into Tc. So TWC is nothing but summation of Te. So n in this case is 5, Tc is 1 minus summation of Te. If you just sum up all the work element times given in the problem, it comes out to be 4 divided by 5 into 1. So it is 1 by 5, that is equal to 0.2, that is equal to 20%. Right, so that's it, that is the balance delay. Right, so that is how you follow the allocation pattern in case of KW method. First you draw the precedence diagram such that elements which are having common precedence fall under the same vertical column. Arrange the elements according to the vertical column, allot it, then you put a finisher table, which is your result table, which I have done it here, and from this you will get to know the maximum number of workstations required, and using this you calculate the balance delay. Right, so that's it for today's session. Thank you. Please share it with your friends. Do subscribe my channel. Have a good day.